Yesterday I showed you this diagram about the state fly past, the state flag fly past. So, and I told you to imagine if you were at point X versus point Y versus point Z, and I asked you to consider the angle of elevation, right? If you are standing at these three different points, what is your angle of elevation if you were to look at the flag? And when the flag is at point A, thank you. When the flag is at point A, most of you could tell me that, oh, X will give us the greatest angle of elevation. Do you all remember why you said that? Why do you think X gives you the greatest angle of elevation? Nearest. Yes. Shafiq said the keyword. Point X is the nearest to A. But what do you mean by nearest? What he actually meant was the distance from X. Okay, watch how I'm drawing it up. From X to this point, the straight line distance. Okay, this red color distance versus this one in green versus in blue. Obviously, the red color one is the shortest, right? So from these three positions, X, this red color distance is the shortest. Therefore, our angle of elevation will be the greatest. And since at point Z, the distance, the horizontal distance, everybody at the end of this chapter must be able to identify the horizontal distance. Because that is one of the key to solving this type of 3D problems. Okay, this one we are now moving into the 3D region. Since the horizontal distance is the greatest, the angle of elevation is going to be the smallest. Okay, now if I change the position of the helicopter, it's no longer at A, now it is at point B. If I want to talk about again angle of elevation at points X, Y, and Z, I need to find the horizontal distance again. Okay, now let's take a look at horizontal distance from X to this point, directly below the flag. So this will be my distance for X, and then in green, this will be my distance for Y, and finally my distance for Z. Okay, which one is the shortest distance? Blue, red, or green? Green. Green is the shortest distance, so we expect him to have the greatest angle of elevation. Again, blue has the smallest angle of elevation. Now the helicopter continues to move to the left, and now it is at point C. Directly below point C is over here. So let us measure the horizontal distance again from all 3 points. This will be for X, for Y, and for Z. Which has the shortest distance? I mean, from the diagram, if it is drawn to scale, it will look like Z has the shortest distance, right? We can calculate the distance for the green color line. We can calculate with all these dimensions. If it ends up being greater than the blue color line, then I know that angle of elevation for at point Z will be the highest because it has the shortest distance. Okay? Everybody understand the logic so far? Some of you dozing off already, right? Because it's so easy. It's okay. At least you didn't blatantly sleep in my class. Okay, so with this in mind, we can proceed on to our 3D problems. Remember, our first topic was bearing, right? So bearing was just 2-dimensional only. For bearing problems, 2D on a flat surface. Okay? Part 2, we had our angles of elevation and depression. Angles of elevation and depression, is it on a flat ground? No, it is now on the vertical plane. We look at a vertical building, a vertical tree. And finally, in chapter 1.3, we get everything together. It is 3D now. We both have the flat ground and we have vertical things, whether it is a building or a flag or a bird, whatever. And we try to solve these problems. Okay? Okay, let us go to your textbook. Page 22. Okay, we start simple. In the diagram, we have a cuboid. So look at the diagram. It is a cuboid. AB is 6 centimeters, BC 4, CG 3. Find the length of the diagonal BH. So identify in the diagram where BH is. So are you ready? Okay, what's your plan for finding this length BH? We have already learned all the skills that we need to have to tackle these types of questions. So BH, what's your plan? Maybe since this is the first time, right, I will give you some help. For 3D diagrams, it may look complicated, but always try to reduce it to one triangle. Most of the time, it will be a right angle triangle. Okay? So BH. Do you see any right angle triangle that you can form? It is actually highlighted for you, isn't it? Let me draw it out. So B, D, and H. This is what I want to find out. Okay, which of these dimensions are... Okay. First thing, is this a right angle triangle? Is it a right angle triangle? You must look at the diagram and be convinced that it is a right angle triangle. How do I know it is one? Yeah, it is a cuboid. So DB, this DB, it is on a flat surface, whereas HD is vertical. If you find it hard to visualize, this is what I need you to do. Everybody look at me. All of you have a pen, pencil, so on and so forth, right? You have a table. So imagine that the table, the flat surface is A, B, C, D. Okay, your flat table is A, B, C, D. Take your pen, put it vertical on your table, and that will be your DH. So now join it down to point, you can use another pen or pencil if you like. Try to join it down to point B. Okay, so this is your DH, this is HB. Join it down on the flat surface. Does it give you a right angle triangle? Yes, it does. That is why I can simplify it out to be this right angle triangle. Okay, right angle. Now, which of these dimensions are already given to you? HD, how much is that? 3, because it is a cuboid. So this over here is 3 centimeters. And now I need to find this length of BH. Any idea how we can do this? Rabiotto says Pythagoras theorem, but for Pythagoras theorem to be used, I need to know two sides, right? I do know it is a right angle triangle already, but I need to know another side. Which side do I need to know? BD. Okay, how to find this? Is this 6? 4? Are you sure? Are you sure? Are you sure it's 4? Why do you think it is 4? Okay, now our plan over here. Use Pythagoras theorem, but I will need to know BD first. Okay, so let's try to find out what BD is. I've got some answers. Somebody said 6, somebody said 4. Somebody said something like 6 divided by 4. But whichever your answer is, can you please think through carefully why would you say that? And are you really convinced that these are the lengths of BD? If you are not convinced, think again. How can we find the length of BD? Okay, the rest, think. Okay, then come and get a pass. How is it? Say again, Francis. Use the triangle below. Do you say below? Okay, let me draw it out. Let me just draw the rectangle at the bottom. It looks like this, right? A, B, C, D. This is 6 centimeters. This one is 4 centimeters. And then BD is over here. Okay? So how to find this BD? How do I find this BD? Okay, Rabiato, you don't tell them the answer. Don't tell them the answer. Is this a parallelogram?
No. Yes, but you need to use.
Is this a parallelogram?
Yeah.
What is this shape?
Compass. That one is parallel. Yeah, it's a parallelogram.
Okay, I give out two choices: parallelogram or rectangle. What is this? Okay, this. Read your first. Read the question. It says it's a cuboid. So everything is made out of rectangles and squares. So what shape is this? Yeah, it is a rectangle, but I drew it this way and a diagram drew it that way because they have to show you that it is 3D, isn't it? So you must know that this is a rectangle. So what are the angles over here? All 90 degrees, right? Now, can you tell me the length of BD? Yes, Pythagoras theorem. We are going to find BD using Pythagoras theorem. This side being 4 centimeters. So BD is going to be equals to square root of 4 square plus 6 square. Okay? Anybody lost at this point? No. Irfan, are you okay? Are you okay? Do you understand? Okay, but do you understand my method? Hoi, do you understand? Anissa, do you understand? Okay, so square root of 4 square plus 6 square. So this is square root of 52. I don't want to evaluate. I don't want to find out the value yet. I leave it at square root of 52. Okay, now that I have BD, this is no need because this is length. I know that I'm finding a length. Lengths have to be positive. Sorry? Yes, yes. In this context, BD is known to be a length. Since we know that it's a length, we don't need to have the plus minus already. It is definitely positive. Okay, so now that we have BD is equal to square root of 52. Can I find out what is BH now? Yes, right. Okay, so this is our working over here. This is our first step. So second step will be BH equals to square root of 3 square plus square root of 52 square. Alright? Do you see why it is useful for us to leave it as a square root of 52 over here? So we square, we get a very nice number 52 again. So my answer will be equals to square root of 61, which is okay, thank you. So you round it off and you will get 7.81 centimeters. Okay? Next, angle DBH. Angle DBH in the diagram it might be a bit hard to visualize, which is why it is good. I recommend that you draw this triangle. Okay? Now that we have all these values, and this is square root of 61, I need to find an angle DBH. This angle. How do I find this angle? Sine rule, what will you use? An angle? Angle D. So square root 61 divided by sine 90 equals to 3 divided. What am I going to say? Square root 61 divided by sine 90 equals to 3 divided by the sine of this angle. Is that it? There's an easier way. You don't always have to use your sine rule. In this case, it is a right angle triangle. Just use your trigonometric ratio. Okay? So for example, sine of this angle DBH is equals to opposite 3 over square root of 61. We can do that. And you find angle DBH. Or we can use your cosine. You can use tangent as well. Up to you. Okay? And your final answer will be in 1 dp since it is angle. So please try it 9 yourself. Try it 9. Everybody should be doing your work, shouldn't be talking. Let's not waste time. Okay, for try 9, find the length of the diagonal CE. So again, we will draw the triangle. Label whatever you can, including this right angle over here. To find the diagonal CE, I need to know what is my length of AC as well as EA. EA, since it is a cuboid, this will be 5. And next, I need to find my value for AC. And I can draw another triangle. This is A, B, and C, 3 and 4. Right? This is the one that is on the flat surface. This is the one that is standing up. Okay? So now I can use my Pythagoras theorem to find AC. AC is going to be equal to square root of 4 square plus 3 square. That gives me 5. Okay? So since AC is equal to 5 over here, I can now find the value of EC. And EC is equal to square root of 5 square plus 5 square. Square root of 50, get a value, round it off to 3SF. Okay? Next, to find the angle ACE. Identify the angle ACE. Based on this, I don't even need to use sine, cosine, tangent, right? How many of you managed to find angle ACE already? How many haven't found ACE yet? Okay, how many found ACE without using trigo? How? I say without using trigonometry. How you look at the diagram, what's your answer? Why? Okay, because this happens to be an isosceles triangle. Since it is an isosceles triangle, then this angle over here will be the same as this angle, and it will be 45 degrees. Okay? Roberto, do you use isosceles triangle? What do you use? Which trigo do you use? Tangent. What was your answer? Huh? You use tangent, right? So if you choose to use tangent ACE equals to 5 divided by 5, which is 1. Therefore, ACE equals to tangent inverse 1, and you get 45 degrees. Right? Okay. So let us move on to example number 10. A little bit more complicated in the diagram. Okay? Okay, come. We only have one period left. There are quite a number of examples that we need to go through. This is a right rectangular pyramid in which AB is 8, BC 6, VC 13. So in this pyramid, you see that the line VN is perpendicular to AC. At the same time, it will be perpendicular to BD, since ABCD is flat. So can you imagine this is a symmetrical looking pyramid. We call it a right rectangular pyramid. So find the length of CN. To find the length of CN, we can draw triangles to help us. Okay, just isolate. This one over here, I've got B, C 6 cm, this N, and this is A, this is 8. To find the length of CN, yes, find the length of AC, and then what do we do after that? Yes, so the plan was to find AC, then AC over 2 will be equals to CN, right? So how do we find this AC now? How to find this AC? Is there something that I haven't included in my diagram? Is there something I haven't included in my diagram? Which triangle? Look at this diagram over here. Something missing. Because what Sophia suggested was correct, to find AC first. But how do we find AC from this diagram? Which right angle? Where is the right angle? ABC. It is a right angle. Once you have this right angle, you can use your Pythagoras theorem again. And do you know why it is a right angle? The question said that it is a rectangular pyramid. It is a rectangle on the surface. So now, to find AC. AC equals to square root of 8 square plus 6 square. What was that? What does that give me? 10. Right? So CN is just AC divided by 2, which is 10 over 2 equals to 5 cm. Right? Yeah, correct. Then now, to find the height of VN. We keep using Pythagoras, right? Is it really the case? VN. Yeah, it looks like it. But this time, draw another triangle. This is N, V, we don't know this. CN, we found it to be 5. C, 13. So Vn, again, we use Pythagoras. Vn will be square root of 13 square minus 5 square. How much is that? Okay, Vn is 12 centimeters. Are you able to identify all these triangles? You need to be able to do it yourself. Then next, NCV. NCV, find this angle. Shouldn't be a problem for you to do it, because we can just use cosine. Cosine NCV equals to adjacent, which is 5 over 13. So NCV will be equals to something, and we round it off to 67.4 degrees. And the last part, volume. Volume of the pyramid. What is the formula? It is equals to 1/3 base area times height. Okay? This height over here is our perpendicular height. So where is this perpendicular height, Ali? Where's the perpendicular height? Where is the perpendicular height of the pyramid? Don't know. The rest know? Vn. Vn is our perpendicular height. Base area, you can find it yourself. It is just 8 times 6. So you have everything already. Yes, so try it 10 yourself now. Am I going too fast? No, I shouldn't be. Green. This is for try 10. There are many triangles that you can identify with the side VM as the unknown. Some may require you to take more steps. Some may require fewer steps. So this is the triangle that I chose, VMC. Please look at your diagram. Can you identify that triangle, VMC? Is that a right angle triangle? Are the dimensions correct? VC equals to 15. And then we have the VM as the unknown. And next we need to find out what is MC first. How much is MC? 5 lah. Okay, this is just 10 divided by 2, which is 5. So with that, I can find VM already using Pythagoras theorem again. So VM square plus MC square equals to VC square. VM will therefore be equals to 15 square minus 5 square. Get an answer, round it off. Okay, that's part A. For part B, to find the height of Vn, we draw another right angle triangle. This time Vn over here. Okay, how much did you all get for Vm? Part A, how much was this? How much? 14.1. You get it, Anissa? Okay, never mind, let me calculate. This is not square root 10, this is square root of okay, so Vm is 14.142. This is actually square root of 200. Okay, so this is square root 200. Nm, how much is Nm? Are you able to find out how much is Nm? Alfian, do you know how much is Nm? Yeah. 5, right? Everybody got 5? This is just 5. So Vn square plus 5 square equals to square root of 200 square. Vn will therefore be equals to square root of square root of 175 is 13.228. Okay? Anybody needs explanation for this? Where did I get 200? From here, Vn. Because I don't like to use all the decimal, I like to keep it neat. Yes? Any comments? What? Okay. Now angle NMV. This one you can do yourself. And finally, the volume of the pyramid you also can do yourself. Okay? Let us move on to try it 11. Okay, try it yourself.